Okay, so today's video is all about smart contract which we will be using and then just creating a signature based lazy minting. Okay, so in signature, the one thing that is gonna benefit us because if we use an offline signature and then give that signature to someone to mint the contract or mint the NFT in the contract, then we don't have to pay the gas fees for the transfer and mint because that user will just mint the contract first to himself, then we can just transfer it to the user, and in that case we will be also keeping record that okay, this guy has bought the NFT from me and then I just transfer it to him. So what we will do is just create an offline signature, and then after the signature is done we can just hand over a signature to someone who will be just buying from us, so we don't have to pay the first initial mint fee. He will be minting it and then he will be transferring it to himself. So that is all the things that we need. First we will just search OpenZeppelin wizard and then just start with the wizard. After the wizard we can just go ERC721, and what I will be doing is selecting mintable and URI storage for the token URI to set up. So we just need this and then we can just hit the open in Linux. So it will just need the dev environment for us to run the smart contract and just work around it. Okay, so I am just starting for the first time in this laptop. So I will just do this, and okay, so once we do that we don't need the ownable one because we don't want the contract to own into the owner because anyone can mint it, so we just use this and this encode is not required. So it is just a simply ERC721 contract. Now what we need is ERC721. We can just copy, I guess, this and just paste it here. I don't know why the copy isn't working. We'll just copy it again. Okay, so now what we need is we can just go to utils, I guess, and then EIP-712.sold. Okay, so it has some errors. Let me just search it. EIP-712. Okay, I will just go cryptography. I guess you know the. So we just copy this, and if we go here and just paste it here, it should import it directly. We don't need this much. Okay, so this is now imported. We just need a comma here. Okay, so I think the error has been resolved. What we just save again. And one more thing we need to import is ECDSA. Let us do the ECDSA. Zeppelin. Okay, it is same from the utils. Just copy this part because open Zeppelin parts are almost similar. So what I will do is I have clicked on this. Just do that and just do this. And I will just do is just save it and just refresh it because sometimes it imports the import directly and sometimes we have to just refresh it. And okay, so after refresh it doesn't save the changes, so I guess we have to. provide it again. Just copy this and paste this. Let's just check if it imports this one. Why it is not importing? It should import it. So we save this again. And we can just copy and we just go over this. Let's just look at okay, so I guess the error has been gone. Okay, so we don't need Onival import anymore, so we will remove this. And now for the main part, we need to create a EIP. I already imported it, EIP-712. Basically, you can just search it, EIP-712. This is an EIP from Ethereum which helps us create a type data signatures. You can read about it all here. It will show the user what he is signing in the pop-up. So I will show you that in the later part where we will be creating a signature for the front end. So that we will using a React application to just read the signature and then just try to mint it. I will be minting it inside this development environment, but we can just try to create something related to it. But on the front end, we will just be creating a signing from the Web3 JS library. So that is that. Okay, so it is giving me an error. It is saying that I should also use EIP-712 here and then just give it something. Okay, so what we need here is just a domain name and a version. So domain name will be voucher dash domain, and what we can do is pass a version. So once that is done, it doesn't require anything else. Now what we can do is inside the constructor. So initial owner, we can just create a variable on which we can just check that who will be the owner who will be creating a signature, and for which we can match that the signer and the owner of this contract is same. So we can just create address of the public variable so that we know what the signer is and we check it. I will just write an intro, and what we can do is just add the initialization of the constructor because constructor is initialized only once in a contract. So we can just set minter equal to initial owner, and it will just save that in state only once. So you can just write immutable also, but this also does the job. So after that, we need a struct just like here because it is a type data signature of that gives us this type data signature option. So we need to create a struct in which we will define what it will be taking in the signature inside. So we just write struct lazy nf2 voucher, and what inside this struct we will be using 256 token ID because we will be assigning token ID to someone, and doing 256 URI. I will not be including the price in this, but you can just include the price and I will show you how you can do that. Just write 256 price here also, and then we can just discuss it later how we will be utilizing that function. Then we can just use scope. So I have done a mistake here. We have to make it string because URI is a string. Then we can just add the address of the buyer for which we are signing. The signer will be someone who is a minter. Like a minter address must be able to sign signature. So we need to pass the signature here in the bytes format because it will be a hash. So that's why we are using byte type. Now we need a function that will be able to recover the signer address. We just pass it the call data of this and it will be able to do that for us. Call data voucher, voucher call data, then we can study public, view branch. If you just return an address, we can just match it with the statement and check that the signer or the mentor and the address recovered from this recovered signature is same. So what we can do is create a byte that will digest. This will just create a signature and this will be type this such signature which we are passing here, this one, and then just try to match both signature and just recover the. Basically, it is a bunch of cryptography, so we are not discussing the cryptography here. It is that. So what the function we need is okay. So inside this library, if you just go there, okay. So we go here. What we need is hash type data function. This one. Just copy this, and this will create a type data version 4 signature for us. So what we can do is right click at 56. This is the encoder that will be encoding our function. So we can do this UGI dot encode and it requires an argument. And in this argument we can just try to because we need to encode the okay, so this is the thing which we'll be using in the front end as well. Lazy NFT voucher. So lazy NFT voucher. So now you have to maintain the types as well on the front end. So you just do that using 56 and the token ID. After that you have to no. After that you have your string URL. Then you have address file. Just that. You don't need anything else. Then we can just use voucher dot token ID. We can just do voucher dot. Okay, so for string we cannot just use voucher dot string. We have to import this in the byte format. So it causes us less here. So we will just need the hash of it. And in the hash we can just use bytes and we pass this URI to convert it into the bytes. Okay, so now after this you can just click voucher dot buyer. Once that is done, you can just close it and after that we have imported one more library. This is the ECDSA. So this will just recover the signer using the signature. We will be passing it in this. So address recover signature equal to this is the storage slot which will store the recover address in the function. So we can just use ESA dot recover, not EC recover. So in the recover we just pass the digest and the signature which will be voucher dot signature and it will just recover the signature. We can just copy this object and return it at the end. So okay, this is done. Now we know that the signature is done and now we don't need these import rules. We will just be passing the signature here, so we can just pass the same object data here. The same object data here. Okay, so after that we can just hit require statement. Okay, so one thing I told you that you can just create a price and then just enter the price variable here and then voucher the price. So what you can do is create this function table and then just hit a require statement that the price is greater than this, which normal pricing of the function and safe main table, and then you can just check the price greater than the sending price is greater than the price you have mentioned in the signature, and then you can just create a require statement for that. So you can use it here, but for this I will just be using like the meter, which I have to define in the top. This variable we will be checking it in the require statement that the mental is equal to recover. So we just hit recover, and inside this recover we will pass voucher, and if it is matches it will just go forward, otherwise error meter is not the signer. Just give the error, or you can just revert it with the revert error. So in that we can just use voucher dot buyer, also voucher dot token ID. We are just directly maintaining, but for if you want to keep a record you can just hit it like the recover address, but for that you need to create a variable here like address recover address creator, and then just hit. If you can do that to show the record that the creator, they can just add argue. I guess if I am thinking correctly, it should provide us. Okay, so this will store the creator. Now we can do is save mint the token to the creator and then transfer it to the buyer, so that we also have some record. At the end, we will transfer from creator to voucher dot buyer, and then just create voucher dot token ID. And voucher dot URI to just get the URI, and now our contract is finalized. Now we will move to the front end and see how the front end is really gonna see. But for that we need to deploy the contract first. So since this is my new laptop, and I will just try to install MetaMask and set up everything in front of me, because I haven't set up on this paper because I was testing it to check if it really worth it to buy. So I just install MetaMask, add it to the clone. So once MetaMask is installed, we can just hit the deployment on the Sequoia. Okay guys, I will just clip out the part, and just because I have to set up the Discord on this, because for the testnet token we need Discord setup, and I'll show you for where you can just get the faucet balance. So I guess let's just search if Polygon in my faucet is electrons. No, I cannot sign it right now. Okay, so we need to create a new wallet. I will just create a fast wallet. Maybe I click out the part, maybe I don't. Please go for it. Yeah, it's not simple. It is. I'll just keep this step, but you have to make sure that you don't lose your wallet. So recover the 12-digit seed phrase. So okay, my wallet address is this now. I can say polygon faucet. Okay, so none of the faucet is free actually. Uh, Here's service of Google Cloud, which provides faucet. Okay guys, I will just leave out the part because I have to set up some things here, just transfer some funds and just try to show you how to deploy the contract and then we can test it. Okay, so I have set up some stuff and I have just signed in my Discord and then you can just go to Polygon Faucet MOI this URL and just click here, this connect Discord, and it will show you the steps to just sign in. But for that you have to join the Polygon server. You can just find it in the Google how to join the server. I have previously shown it some videos of mine, so you can check that out. Otherwise, you can just search and check from where you can just join the server. So once you have done that, you can just click Polygon Post MOI Matic and then paste the address and just submit, and it will just try to add some faucet. So currently it is not showing in my network. For that you can just go to MOI.polygon Polygon scan. Or you go here, you can just add Polygon output. Just switch, and once you switch, you can see that it has the testnet token which we acquired. So after that, you can just go to the model, go here, go here, go here. This in this is the also it is not showing injected provider. Don't know why, but disconnect the wallet. MetaMask. It will open a wallet and then use okay, I don't know why. Sometimes it does that, but we will not be seeing this pizza network. Just waste the time. It is here. Just deploy it. And once you hit deploy, automation will pop up and you will just sign it. Hit confirm, just wait for the transition to be confirmed. And once the transition is confirmed, you can just go inside the okay, so transition is confirmed. We now have our address.